Well, the question here says rectangles of width 1 centimeter are drawn from the edge of a sheet of paper that is 30 centimeters long, such that there is a 1 centimeter gap between one rectangle and the next. The length of the first rectangle is 21 centimeter, and the length of each successive rectangle is 85% of the length of the previous rectangle. Excuse me. Until there are rectangles drawn along the entire length of AD. Each rectangle is colored gray. Now, question 1 here. I'll move the paper here. Says what? Calculate the length of the 10th rectangle. Right. Now, let's first understand the problem. I'm gonna write here 3.2, over here 3.2.1, 3.2.1. The question says calculate the length of the 10th rectangle. So we're looking for T10 in this question. All right. If you look at this question, this rectangle here, the width of the rectangle is 1 centimeter. And then they said like the 1 centimeter gap, okay, of between this and that rectangle, the gray rectangle, 1 centimeter gaps between the gray rectangles. Now, and then it is given that the first rectangle T1 here is equal to 21 centimeters long. The first one, this one, is 21 centimeter long, and the following will be 85% 85% of the previous rectangle, and so for each rectangle. So meaning if T1 is 21 centimeters, T2 will be 21 centimeters times 85%, okay, 85%, and then T3 will be 21% times 85%, which is T2. This is T2, but it is actually, okay, let me write this way. Because over here it is said that each successive rectangle is 85% of the length of the previous rectangle. Okay, so T3 will be then T2 times 85%. Okay, but we do know T2 is from the previous, T2 is 21 times 85%. So now this is T2. This is T2. Now 85% of E2 we times by 85% again. And then this can be written just 21 times 85% to the power of 2. Okay, let me go over it one more time. The first, the length of the first rectangle is 21 centimeter. This one, 21 centimeter long. Now, the second rectangle must be 85% of this 21 centimeter. Okay, so to get 85% of this amount, we do 21 times 85%. Okay, now this is 21% times 85%. Now, the following rectangle T3 will be T2, the length of the previous rectangle, which is T2, but 85% of that length, which is a T2 times 85%. But T2 originally was 21 times 85%. So we're going to take 85% of that amount again, which is that. And then it's going to be so T4 now will be 21 times 85% to the power of 3. So these rectangles are like, the length of the rectangles are like 21 times 85%, and then 21 times 85% to the power of 2, and so on and so forth. Then we can notice that we have a constant ratio in this question of 85%. Okay, and then 85% is important to know that 85% is just 85% is just equivalent to 0.85. Now, because there is a constant ratio, we understand that this is a geometric pattern. Okay, so the geometric pattern is given by the formula Tn equal to AR to the power of n minus 1. Now, where R over here, we did find that R is 85% as we said, and then which means R is just 0.85. Then we can then answer the question to find T10. T10 will be the first term, 21, so 21A times R, 85%. So I'm gonna write 0.85. Okay, to the power of n. So n here is 10. Because let's substitute n by 10 minus 1. Following the formula written above, then T10 will be equivalent to, I'm going to use my calculator. Well, I'm going to use my calculator. Okay, here's the calculator. So now I'm going to type in the values like 21 and then open brackets, 0.85 to the power of 10 minus 1. So when we hit equal, then we can see that the 10th rectangle will be 4.80, let's see again, 86%, okay, 86, not percent, but 4.86 centimeters. So we're talking about the length of the 10th rectangle. Then let's see now question 3.2.2 says calculate the percentage of the paper that is colored gray. All right. I'll write the question over here. 3.2.2. The question says calculate the percentage of the paper that is colored gray. Now, you notice that the whole paper is what we see over here. This is the whole paper. Okay, this one, this is the whole paper. Oops, I don't know how to draw. So thinking about this is the whole paper. Okay, approximately. Anyway, I just wanted to show, never mind about it. Now, it's not whole paper that is colored gray, only this part are colored gray. So first of all, we can find the area of the whole paper, okay? The area of the whole paper will be, we know that the area of a rectangle, because this is a rectangle, the paper is a rectangle, area of the rectangle is given by length times breadth, okay? And then this is equal to, the length is 30 centimeters, as it is given over here, 30 centimeters. So we have like 30 times 21. The width is 21 centimeter over here. Now the area will be equal to 30 times 21. If we do 30 times 21, I meant to write 30 times 21, and then this is equal to 630. So we're gonna just write here 630 centimeters squared. This is the area of the whole paper, okay? Now, we don't want the area of the whole paper, we want just the parts that are colored. So we need to find the area, this area. So we're gonna find, let's call this one area 1, plus area 2, plus area 3, plus area 4, plus until we find the last rectangle colored gray. Now, how can we get that last rectangle then? Okay, we don't know how many rectangles are here so long, but we need to find how many until we like to find the last, assuming that the last rectangle is somewhere there, because there is a 1 centimeter gap between the rectangle. So now, meaning from here to there is 2 centimeters. And from that to there another 2 centimeters, because this length here is 1 centimeter, and then 1 centimeter space, okay, and then 1 centimeter again for the rectangle, and then 1 centimeter space, and so on and so forth. So maybe I should just color it like this. Let's do so we have like 1 centimeter here, okay, 1 centimeter over here, and then 1 centimeter there, 1 centimeter there, 1 centimeter there, and then there must be another 1 centimeter over there. Now, but there is a space here. The space here, gap, 1 centimeter gap again, another gap, so on and so forth. Meaning, if you need to find a number of the rectangle, okay, we're going to look at the base, which is the width here of the rectangle. So this will be it's going to be like 2 to reach another rectangle. So the total number will be 30 because the length is 30. Because the length here is 30, we're going to do 30 divided by 2 centimeters. So this is equal to 15 centimeters, 15 rectangle. Okay. So there are 15 rectangles here from there to there in total. Now, what should be then? Okay. If I need to find now the sum of the area of all these rectangles, I can use, because in the previous question we did say that it was a geometric pattern, so we can find the sum of 15 rectangles here. Okay, it's the sum of the area of the 15 rectangles here. So this will be excuse me, move black. Going to be the sum of 15 rectangles, okay, S15. Before, okay, let me get back here. So I guess you guys got why I said, okay, I want to go over it a little bit one more time to try to be more specific. We said that because the length of this rectangle is 30 centimeters, okay, 30 centimeters given over here, you see there? Because the length is 30 centimeters, and then because there is the width of each rectangle is 1 centimeter, and one more gap separates the rectangles, meaning the total number of the rectangle over here must be 30 divided by 2, which makes 15. Okay, so in total, meaning we have like 15 rectangles from there to there, okay, of base or width 1 centimeter. Now, we are going to calculate the sum of these rectangles, A1, A2, A3, A4 until A15. Okay, now, so we know that the area, as I said, the area of the rectangle is length times breadth. So here the breadth is just 1 centimeter and the length is 21. Over here 1 centimeter and then 21 times 85%. 1 times the previous rectangle times 85%, and so on and so forth. So we are basically going to calculate the sum of 15 rectangle. So Sn is given by, because the geometric pattern is given by A, open bracket, 1 minus R to the power of n. I use this formula because, you know, when the ratio is between -1 and 1, the convenient formula is this one, okay? 1 minus R, instead of saying R to the power of n minus 1. So I use this one, and then we're going to substitute then the values. Sn. A is the first term, so the first area will be 21 centimeters squared. So I write 21 there, okay, open bracket, 1 minus R to the power, so 0.85. I'm meant to write here S15. So like S15 to the power of 15, okay, close bracket, all over 1 minus 0.85, that's 85%. Now, S15 would be equal to, I'm going to use my calculator now, then we're going to sub in 21, okay, let me just say like this, 21, open brackets, 1 minus 0.85 to the power of 15. Okay, we close the bracket, all over 1 minus 0.85. Okay, when you hit the enter, we hit enter, and then we have like 127. So S15 is 127.77. So that will make 127.77. That's S15. Now, this is the total sum of all the area over here, all the gray area, okay, of the gray area. But now the question didn't say calculate the sum of all the area. The question says calculate the percentage of the paper colored gray. So now that we got this sum, to find the percentage, we're gonna take this area, the area of this gray, of the rectangle colored gray, divided by this times 100. Okay, it's like if, for instance, you got like the test is on 150 marks, for instance. Let's say the test is on 150 marks, out of 150 marks, and then you got like, let's say, 120. Okay, those are the marks that you get in the test, and the total marks is this. So what you do to find the percentage, you do 120 divided by over, which is divided by 150, and then times by 100. That's how you get the percent. You can say then I got 80%. Okay, so we're gonna do the same thing over here. We will, to find the percentage of the gray colored rectangle, we will do it's gonna be 127.77. Okay, divided by 630, because this is the area of the whole paper. Okay, multiply by 100%. You multiply this by 100%. Now, using a calculator, we will do 127.77 over 630, and then we times it by 100%. So the calculator is going to say 1 times 100, and then when we hit equal, and then this is the result. So this is approximately, the area is approximately the percentage area, and I say here is approximately 20.28. If you see this, this is the recurring part. Okay, this part is repeating over and over and over, the same, those digits. So because it's 0 over here, I can just stop by 28. So this is going to be 20.28%. Thank you.